So we're in section 13.7. So expected value is we're using probability to decide what should happen in the long run, or to tell so expected value doesn't tell us what is going to happen necessarily on the next time we do something, but in the long run. And we use it to make decisions when we know something about probabilities. And expected values are a really powerful tool for making decisions when you're talking about gambling, when you're talking any kind of game of chance, any kind of investment that has a probability of gaining or losing. So it's really a good way to use the probabilities to help you make a decision. So I'm going to tell us how we calculate it, but we'll do a couple of examples, and the examples really will help it make sense. So to calculate, we're talking about, we have a probability and we have some kind of outcome, something that we can win, something that we can gain, something that we can lose. So something that has a value. So we multiply the probability times the value. And that's really all we have to do. If we want the probability, if we have multiple events, remember, events are just something that we're interested in, something that we're interested in. So if we have multiple events, we find the total expected value by finding the expected value of each piece and then adding together. And I'm going to use EV for an abbreviation so we don't have to keep writing it. Finding EV for each part. And then we add all of them together. So we have some kind of value, something, a prize, money, whatever. We multiply the value times the probability of that thing happening, and that's the expected value for that thing. If there's several things that can happen, we find the expected value for each piece, and then the total expected value we find by adding together. So let's take a look at a couple of examples. Before we move on, when we're talking about expected, what do we mean by expected? What does expect mean? What's going to happen? What we think is going to happen? Is it a guarantee? Expected value is not a guarantee. It's what we think might happen, and that's why I say, tell us what should happen in the long run. We're talking about probabilities, so it's not a guarantee. So expect means what should happen, what we think might happen. That's what we mean by expected. It's not a guarantee. All right, so our first example, we're playing a game. You're at a fair or something, and you buy a game ticket. When you buy this ticket, you have 70% chance at a $1 price. You have a 25% chance at a $5 prize, and a 5% chance at a $50 price. So we buy this ticket. These are the things that we could win when we buy the ticket. We want to find the expected value of the ticket. So in the long run, if we bought this ticket, what do we think is going to happen? So we have 3 pieces. We're going to find the expected value of each piece and then add them together. So our expected value, I'm going to use EV for my abbreviation so I don't have to keep writing it. We're going to find the expected value of winning $1, the expected value of winning $5, and the expected value of winning $50. So 70%, the expected value of $1, multiply the probability times the value. 70%, how do I write that? 0.7 times the value is just $1. So that's the expected value of this piece. Plus 25%, how do we write that? 0.25 times the value times 5 plus 5, how do we write that? Be careful with this one. 0.05. 0.5 would be 50%. So we move the decimal place over to 0.05 times $50. The value is 50. So when I multiply this out, 0.7 times 1 is just 0.7. 0.25 times 5 is 1.25. 0.05 times 50 is 250. And my expected value, my total expected value, when I add those all together, comes out to be $4.45. So in the long run, if you buy this ticket multiple times, you would expect to win about $4.45 when you buy the ticket. So how do we use this to make a decision? What if the game costs $5 to play? Would it be a good deal? Why not? The expected value is less than what you pay. So if you pay $5, you're going to expect to lose 35 cents in the long run every time you play. You might get $4.45 occasionally, but if you play it over and over and over again, you would expect to lose about 35 cents every time you play. Now if the ticket were $4.50, the expected value, so you'd lose, in the long run, you'd lose 5 cents every time you play. But the expected value is $4.45, so that's a little closer. If the ticket were $3, then it would be a good game to play for you. It would be bad for the people who are trying to make money off the game. So if the expected value is more than what you're going to pay, then it's a good deal. If it's less, then you're going to end up, in the long run, losing money. And this is how a lot of carnival games work. They make it seem like, well, you have this big prize, but you have a very small chance of winning. Usually you're going to win a smaller prize. So the expected value for your prize goes in the favor of the people who are running the game, because you end up paying every time that you play the game. The expected value of the prize is less than what you're paying for the game. Questions on that example? The expected value of the ticket is $4.45. We just calculate the expected value for each piece and add them together. And then I just added on, would it be a good deal if it cost $5 to play? So that's how you would use it to make a decision, is if you had to pay $5 for the game, you might decide not to play. You paid $4.50, you're losing 5 cents, but you stand to gain $4.45. All right, let's look at another example. We have an investment. And we have our stockbrokers calculate this out and says that we have a 30% chance to earn $4,000 if we make this investment. We have a 60% chance to lose $1,500 and a 10% chance to earn $1,000. So notice what happens when I add all of my probabilities together. 100. So we've taken all of the possibilities into account. There's not some mysterious thing that could happen that we haven't accounted for. And if we look back at our other example, if we add these all up, we get 100%. So that's all the possibilities are taken into account. It would be, if you don't have all the information, you can't really calculate an expected value because there's some mysterious probability out there that you don't know what's going to happen. So before we even start, we know that to calculate our expected value, we're going to calculate it for each piece and then add them together. What are we going to do with this one where we could lose money? Subtract. If we have a chance of losing, we're going to subtract. So we're going to subtract that piece from our expected value. So our expected value for this investment is going to be the expected value for this piece. How am I going to write that? 0.3 times 4,000 minus, there we go. I'm going to put that in red, minus, how am I going to write that part? 0.6 times 1,500, and we're earning plus 0.1 times 1,000. Calculate that out, plug this into my calculator. 0.3 times 4,000 is 1,200 minus 540, because I can lose that amount, and I'm going to do a plus 100. 0.1 times 1,000 is 100. I add that together and I get $760. So if this were an investment, would you recommend this investment?
get 760.
So in the long run, you would expect from this investment to get $760. So you're investing something somehow, so in the long run you'd expect to get $760. Now I don't know if you want to make more, but the expected value is positive. If we calculated this out and our expected value came out negative, what would that tell you about the investment? What's that? That you don't want to make it. And big picture, what's happening if you have a negative investment? You're losing money. In the long run, you would lose money if your expected value is negative. So if your expected value is negative, that means you're losing, basically. So that's what a negative expected value tells you. Am I guaranteed if I make this investment to get $760? No. It's not a guarantee. It's what we think will happen in the long run based on these probabilities. We could earn more, we could earn less. But in the long run, we would think that it would be $760. Yes? Did I calculate that? Yes, I did calculate that wrong. Oh, I see what I did. I wrote okay. Yes, so this should be minus, you're right, minus 900. Thank you. In what I wrote down on my piece of paper here is 0.6 times 900 instead of 0.6 times 1500. So let's recalculate here. So this comes out to 400. So our expected value is still positive, not a great investment, but depending on what we're investing, it's still positive. Maybe it's a very safe investment that doesn't grow very quickly. So we're still positive. Everything we said still comes out the same. Still not a guarantee. We still could lose money. We still could make more. So what we think will happen in the long run. So questions on expected value? All right, I want to talk really quickly about one of the problems in the homework, which I think is kind of nice. So let me open up to that. So this is in your homework. This is number 15. So I'm sorry? No, this is tonight's homework. The homework that you're doing tonight. So I just want to give you a preview of how you're going to do this one problem. I really like this problem. So we have a multiple choice test. Is what problem number 15 is about. And we earn 1 point for a correct answer. And we lose half a point for incorrect. If we don't know the answer, the problem asks us to find the expected value of a guess. So the expected value of a guess. How many points would you expect to get for guessing? Well, if we earn 1 point, so that's the value of a correct answer. We lose half a point, that's the value of the incorrect answer. So the expected value of our guess is our probability times our value. What's the probability of guessing the correct answer if there are 4 choices? What's the probability of a correct guess? 0.25, 1/4. Times the value plus the expected value of our loss. Now we're losing, so what do we do with that expected value? We subtract minus. What's the probability of guessing incorrectly? 0.75. We have 3 chances out of 4 of guessing incorrectly. 3/4 is 0.75 times 0.5. So our expected value, 0.25 times 1 is 0.25. Minus 0.75 times 0.5 is, someone come up with that for me? What is it? Oh, you did 0.375? So 0.25 minus 0.375, what does that come out to? Negative. Someone calculate that for me?
Negative 0.125.
So your expected value is negative. Should you guess? No, not for this type of test, because your expected value for guessing is you lose about 1/10 of a point for every guess. Yes?
How did you get 0.25 to 0.75 and how did you figure out?
So it's a multiple choice test. There are 4 answer choices.
Oh, okay.
So 1 of the 4 is correct. 1 out of 4. You have 1 chance out of 4 of guessing the correct answer. The other 3 are going to be incorrect. So 3 chances out of 4 are incorrect. So that's how we came up with the probability. So I want to go through that one because it's kind of a nice example, and 2, you had to come up with the probabilities on your own. So if you wrote that one down, you have number 15 from your homework done already. All right, questions on expected value.